Hello students. Today we will study a new topic, hybridization in the chemical bonding. Chapter number 4, chemical bonding. This is the most important topic as it is very important on the point of view of the structure of the molecules. As you know how water looks like, how carbon dioxide looks like, the different types of the compound, their structure can be determined or identified by the process of hybridization. In this previous topic, we have studied about the VSPR theory, chemical bonding in ionic bonding, chemical coordinate and covalent bonding. Different types of bonding you have already studied. This is the last topic, but it is very important topic. In second chapter, you have studied about the different types of orbitals, s orbital, p orbital, d and f orbital. The shape of s orbital is spherical, p orbital is dumbbell, d is double dumbbell and f is diffused. You know all? Okay. When these orbitals when mixed together, they form a new hybrid orbital, and this phenomena is known as hybridization. Suppose you are going to mix s and p orbital. What will happen? This is the s orbital and this is the p orbital. As you know that there are three types of p orbital along the different directions: px, py and pz. This is px, this is py and this is pz. Okay. Then anyone when it will be mixed with the s orbital, then it form a new hybrid orbital. This structures will be look like this. This is sp hybridized orbital. Okay. This is sp hybridized orbital. Means hybridization is what? Hybridization is the mixing of different atomic orbitals. Either it will be mixed with s and p orbital, sp d orbital, spd. Only these three will be mixed, not f will be mixed. This will not mixed. Only sp d orbital will mix together, because f orbital's shape is diffused, so that it will not be able to find out the structure of the molecule. Okay. So what is I am saying about this? The mixing of different atomic or mixing of different atomic orbitals. Okay. For example, just suppose that we are going to mix one s orbital and two p orbital. Then what will it form? It form sp2 hybrid orbital. Okay. sp2 means what? How we will mix it? This is the s orbital and this is the p orbital. We are going to mix it. P orbital like this. This is the p orbital. This is the p orbital. This is the s orbital. This means that we are taking one s orbital and two p orbital, and then when they get mixed together, they will form a new hybrid orbital. This is called sp2 hybrid orbital. Do you know what is the structure of sp2 hybrid orbital? sp2 hybrid orbital has structure trigonal planar. Trigonal planar. And the bond angle is 120 degree. Okay. Here sp hybridized orbital has the structure linear and the bond angle comes here 180 degree. Understood? These are about when we are going to mix s and 1p orbital, we get sp orbital with the structure linear and the bond angle 180 degree. And when we mix 1s orbital and 2p orbital, then we get sp2 hybrid. 2 will be on the head. sp2 hybrid orbital. And this on this molecule, the structure will be trigonal planar with the bond angle 120. Actually, it will be written like this. This is the trigonal planar structure, and the molecule will like this. Okay. And each and every molecule has the bond angle 120 comes. The two molecules of the compound will have the bond angle comes about 120 degree. Okay. Understood? Now, if 1s and 3p orbital will mix together, if 1s and 3p orbital will mix together, then it will form sp3 hybrid orbital. What is name of this? This is its structure will be tetrahedral. sp3. This is the tetrahedral structure. Okay. Here the bond angle, this structure will be tetrahedral. And the bond angle comes here 109 degree 28 minute. Normal bond angle is 109 degree 28 minutes from with the individual molecule. From each angle you will find out, then you will get this type of this angle. Okay, this is the tetrahedral angle. And when you will mix with 1s, 3p and d orbital, then what will happen? It will form similar. देखो जैसे है वैसे same here, sp3d, sp3d. This will be its structure will be like this: trigonal planar. This is the simple structure: trigonal bipyramidal. Trigonal bipyramidal structure. Okay. We are only learning these structures to know the structure of the molecules. There is molecules which are suppose that you have given carbon dioxide and you have given that find out the structure of carbon dioxide, water, methane, ammonia, different types of molecule you know about them, but you don't know the structure of these molecules, how they looks like in their structure. So this will be like this. Okay, where 1s, 3p and 2d will be mixed together. Okay, then it will form sp3d2. This is the octahedral. Okay, I am going to make the structure of octahedral here. This is the structure of octahedral. This is the octahedral structure. Okay, the molecules which have the sp3d2 hybridization, this will have octahedral structure. Understood? And some special cases are also here. When 1s, 2p and d, 3p and d orbital are mixed together, then we have already got here sp3d. When 1s, 2p and d orbital will mix, then it forms dsp2. This is the special case. This is the special case in which the hybridization comes to dsp2. The dsp2 hybridization will have the structure square planar. This is the square planar structure with the bond angle 90 degree. Okay, and another is the special also 1s, 3p and 3d. Then it got sp3d3. Okay, this structure comes here distorted octahedral. Distorted octahedral structure. This is all about the hybridization, in which we got this type of hybridization: sp hybridization, sp hybridization, sp2 hybridization, sp3 dsp2, sp3 d d2, sp3 and sp3 d3. There are these different types of hybridization we have studied now here. And now we will study about the structure of the molecule, which hybridization comes on their structure, which hybridization will come into their structure. This has some rules that you have to follow these rules, and then you will find out the structure of these molecules. Okay, now there are s orbital has only one, p orbital has 3, you know already, you are familiar about all these things. The d orbital have 5. So when 1s, 2p is mixed, then it will form sp2. I am asking questions some to you. When 1s, 3p and 2d mix, then what will form? Just speak me. Then it will form sp3d2 hybridization. This means the octahedral structure. This is the basic platform of the hybridization, and after that we will study about the structure of the molecule. For example, just I am going to explain some rules that are important to find out the structure of the molecule. Just remember here, CO2. For example, this is the simple molecule. What is the name of this compound? This is the carbon dioxide. Okay. Then we will find out the structure and hybridization of this molecule. There are some rules which will be written here, and you have to remember it. First is the total valence electron. Total valence electrons. Second, number of bonds. Third, electrons for octet. Fourth, lone pair of electron. Fifth, orbital. You have to remember all these lines. Okay. Orbital needed. Hybridization. Structure. Shape. Bond angle. This will be all be collectively be explained by the structure of the molecule. This structure. तुमको अभी किसी भी, if you have given any one of the molecule, then you have to give any one of type of molecule, then you have to write this also, and then you have to fill the data. Okay. Total valence electron. How much valence electron here? Carbon has 4 valence electron, oxygen has 6. Then what will be? Carbon has 4, oxygen has 6 multiplied 2. What will be the 6 2 ja 12, 12 4, 12 4 16. This will be equation 1. Okay. Here total number of bonds. How many bonds? The molecule, how many number is going to attach here? There are 2. The total number of bond is 2. This will be equation 2. Understood? Here electron for octet. Octet means the number of molecule which is going to attach here. It will be multiplied by 8. Octet means 8. So it will be multiplied by 8. 2 multiply 8 is equals to 16. It will be equation 3. Okay. Now we will find out here the lone pair of electron. How we will find out the lone pair of electron? Then we will find here 1 equation minus 3 upon 2. 1 equation minus 3 upon 2. Then what will be happen? This will be 16 minus 16 upon 2 is equals to 0. This will be equation 4. Okay. Now orbital needed. How it will be? It will be equation adding equation 2 and equation 4. What will be the value come? 2 plus 0 is equals to 2. Now here it orbital needed means 2. This means that there are 2 orbitals are going to be needed here. This means that S and P. There are 2 orbitals, 1 S orbital, 1 P orbital. Total is 2. So it hybridization comes here SP. So then SP hybridization has the structure linear. Shape is also linear. Listen, here structure and the shape will be different. If there will be lone pair of electron. If the lone pair will be present, then the structure and the shape will be different. If there will no any lone pair will be present, then the structure and the shape will be similar. So it will be also have linear structure, and the bond angle, as you know, 180 degree. This is the process by which we can find out the hybridization of the molecule.